morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about organization of a computer. So, what is the computer and how we are organizing in a system, in a CPU? So, a digital computer system exhibits an interconnection of digital modules such as registers, decoders, arithmetic elements, and control logic. These digital modules are interconnected with some common data and control paths to form a complete digital system. Moreover, digital modules are best defined by the registers and the operations that are performed on the data stored in them. The operations performed on the data stored in registers are called micro operations. Okay, so how we are organizing in a computer? Okay, in a computer, how we are organizing? So what is important means we need one memory and IBO. In this memory, what we need some registers and input outputs like this and peripherals. So this computer system exhibits interconnection of digital modules such as register, decoder, arithmetic elements. These digital modules are interconnected with some common data and control paths to form complete digital system. So when I'm going for the digital module, the registers and the operations that perform in the data stored in that one. The operations performed in data stored in micro operations. So micro operation is an elementary operation performed on the information stored in one or more registers. The result of the operation may replace the previous binary information of a register or may be transferred to another register. Some examples I'm taking micro operations are shift, count, clear, and load. The internal organization of a digital computer is best defined by the specifying the set of registers it contains and their functions, the sequence of micro operations performed on the binary information stored in the registers, the control that initiates the sequence of micro operations. Okay, so when I'm going for the micro operations means going for the shift, count, clear, and load. So these are micro operations I'm taking as a elementary operations performed on the information stored in one or more registers. The result of the operation may replace the previous binary information of a register or may be transferred to another register. Okay, so this internal hardware organization of a digital computer is the best defined by the specifying the set of registers it contains, their function, the sequence of micro operations performed on the binary information stored in the register, and the control that initiates the sequence of micro operations. Okay, so these are the specifications. So the set of registers, I'm taking the registers R1, R2, so on, and their functions. The sequence of micro operations, I'm taking the shift R1. Example, I'm taking shift R1. These micro operations are binary information stored in the register. Okay, these registers are stored binary operations, and the initiates in the sequence of micro operations. Okay, the sequence of operations or instructions are important. The internal organization of a computer is defined as set of registers and their functions, micro operations, set of allowable micro operations provided by the organization of the computer, and the control signals that initiate the sequence of micro operations to perform the functions. Okay, so the internal organization of a computer, how the internally organizing the registers and their functions, the micro operations of allowable micro operations provided by the organization of a computer, and the control signal initiate the sequence of micro operations. Okay, shift, rotate, call function. So these are the symbolic notation to use to describe the micro operations transferred among the registers. Suppose I am taking call at 9. Okay, some special characters also we have to use. These register transfer languages, the organization of a computer is a register transfer language, register transfer, bus and memory transfer, arithmetic micro operations, logic micro operations, shift micro operations, and control memory, address sequencing, microprogram example, and design of control unit. Okay, these are the organization of a computer. So register transfer language means one register to another register. Suppose R1 equal to 5. So this 5 value I have to transfer to another, R2 equal to 5. Okay, register transfer means the value of register is transferred to the another, shifting the register values. Next one is a register transfer. Okay, registers are transferring means one memory to another memory. Suppose in this block R1 is there, I have to shift to this R1. Okay, we are shifting or converting from one memory to another memory. Bus and memory transfers. Okay, bus and memory transfer means already we know that how many types of buses: address bus, data bus, and control bus. This bus and memory transfers are there. For the memory transfer, we have to transfer the primary memory into the secondary memory. Secondary is converting to the primary memory. Okay, this bus and memory transfers and arithmetic micro operations. Arithmetic micro operations means already just now we discussed shift, call function, and rotate. Like these are the arithmetic micro operations and logic micro operations. Okay, arithmetic and logical operations. Logical means AND gate, OR gate, NOR gate. Like this logic operations I am performing, and or not. These are the logic operations. Shift micro operation, shift left or shift right. Okay, R1 to R1 tends to R2 to R1. Okay, shift left or shift right. And control memory. Okay, we are controlling all the memories in a CPU. And address sequencing. Okay, in the memory, M of AR means address register in the particular memory, and that is the address sequencing. And micro program example, micro programming means we are taking the micro operations of this one. And design of a control unit. Okay, in the control unit we have to designing of a control unit. The symbolic notation used to describe the micro operation transfers among registers is called a register transfer language. A register transfer language is a system for expressing in symbolic from the micro operations sequences among the registers of a digital module. Suppose I'm taking the symbolic notation used to describe the micro operation. Suppose I'm taking shift operation. This shift micro operation, it is transfers among the registers. Shift R1. Okay, so shift is a operand operator. So these notations of micro operations are transfer among the registers is called register transfer language. Means we are transferring the registers from one operation to another. A register transfer language is a system for expressing in symbolic form the micro operation sequences among the register of a digital module. And what are the basic symbols of register transfer language? Okay, so first letters and numbers I'm taking denote as a register. Example, MAR, memory address register. MER, memory address register of R1, R2. And it is describing symbol is denotes the part of register. Means R1 equal to 8-bit, R1 of 07 means bracket means denotes the register. Means suppose I'm taking here R1. R1 is a 8-bit or 16-bit. Which one? Okay, it will be specifying as a 8-bit or 0 to 7-bit. It is specifying. Okay, it is denoting that what is the length of the register. And it is the less than or equal to denotes a transfer of information. R2 to R1 means in the R2 the value of R2 is transferred to the R1. Okay, specify two micro operations of a register transfer. Okay, I'm specifying the two different registers, R1 to R2, R2 to R1, like this. And it will be denotes the condition operation. Okay, P R2, it is a R2 less than R1, then only it is condition. If P equal to 1, okay, if means condition. Okay, and P also it is a condition. What is the condition? R2 less than or equal to R1, then only the condition will be satisfied, otherwise not satisfied. And naming the operator like this denotes another name of an already existing registers, RA2, R1, like this. Okay, so these are the basic symbols of RTL, means register transfer language. So letters and numbers denotes MAR, MDR, memory data register, memory data register. So memory address register and memory data register, and these are the denotes of a registers. R1 8-bit or R1 equal to 0 to 7, and there are denote the transfer of information from one register to another register. multiple micro operations of multiple registers and the conditional operations. And another we are taking the existing to the next alias. Okay, one register to other, like this. These are the register transfer language. And connecting registers in a digital system with many registers, it is impractical to have data and control lines to directly allow each register to be loaded with the content of every possible other registers. To completely connect end registers is n to n of n minus 1 lines is a cost high. This is not a realistic approach to use a large digital system, but instead take a different approach. Have one centralized set of circuits for data transfer, have control circuits to select which register is the source and which is the destination. Okay, how we are connecting the registers. Okay, suppose I'm taking two different registers, R1 and R2. In a digital system with many registers, are impractical to have data and control lines to directly allow each register to be loaded with the content of every possibility of other registers. To completely connect end registers and completely means n of n minus 1 lines. Cost is very high when we are connecting the multiple registers, and it is not a realistic approach to use in a large digital system. And instead of taking a different approach, have one centralized set of circuits for data transfer, or the bus have control circuits to select which register is source and which is the destination. Okay, the source register and the destination. Suppose I'm taking source equal to R1, destination equal to R2, but it is changing the R1 to R2 means source to destination, but I want to transfer to R2 to R1 now. Then I have to change the source to destination again, but sometimes it is not possible to change and the source and destination. It is the block diagram of organization of a computer. I am taking it is a central processing unit. It is the CPU. In the CPU, what are that means? ALU, control unit, and memory unit. Memory unit is nothing but a registers. Okay, so these registers I am taking as a memory. Okay, so control unit and memory interconnection with bus and ALU and also interconnections. These are connected to main memory, disk or monitor. Okay, so these are the input outputs. Disk and main memory are the peripherals. So these peripherals are disk and monitor. Okay, we are connected with bus. So we already know the bus is the address bus, data bus, and control bus. Okay, main memory means a primary memory. Disk is a secondary memory. So in this primary memory is connected to CPU and is connected to input output like this. When I'm going for the secondary memory, okay, suppose I'm taking secondary memory is a disk or hard disk. Hard disk or external memory. Okay, so this external memories are connected to disk or monitor. Okay, this monitor is a output to the CPU, and the disk is the input to the computer. So input and outputs are internally connected. Input output devices are connected to the CPU. Okay, these are all called peripherals or external connections to the CPU. So ALU and CU and the registers are under the CPU. This CPU is connected to main memory that means connected to input outputs. Okay, already we know that memory is connected to input output and it is connected to CPU. Okay, memory is interconnection to the input output and CPU. Okay, so it is operating the input output, it is operating to the CPU. So it is another block diagram of organization of a computer. So already we know that memory to CPU and CPU to input output. So this memory is connected to CPU. How means there are through the bus, address bus, data bus, and control bus. Okay, 3 lines are there. MAR means memory address register. Okay, this line about address. Data means about data. Which data is there? Memory data register. And it is a control unit. It is about the controlling. Okay, so memory address register is connected to input output. Data MDR connected to input output, and control unit is connected to input output bus. Input output interfacing, and is connected to device. Input output interfacing connected to the device. Okay, device is nothing but a peripheral. So input output is I'm taking as a monitor. It is connected to CPU. Okay, what it may be, I'm connected to monitor or CPU. Okay, it is one example. In the previous slide we discussed it. Here I'm taking disk and monitor are the input outputs are connected to CPU. Here also input output interfaces are connected to the input output are connected to device. Device means or it is a input output connections or peripheral devices. Okay, maybe a external memory or maybe a monitor, maybe a printer or whatever may be. I'm taking printer, mouse, keyboard, etc. Okay, these are the input outputs. So it is an accumulator general purpose register. In the previous class we discussed accumulator is a one type of operation and GPR is a general purpose register. It is one type of operation for using the accumulator, and the general purpose registers are for using the instructions. Okay, so memory is connected to CPU. In the CPU, arithmetic logic unit, program counter, and instruction register. Okay, ALU, PC, IR, arithmetic logic unit, PC, program counter, instruction register. Okay, this memory is connected to MAR, MDR, CU, memory address register, memory data register, and control unit. It is connected to bus. It is connected to input output bus. So input output interfacing is connected to the externally connected to devices. Accumulator and general purpose registers are using for the instructions. Okay, instructions is operating to the CPU or program. It is another block diagram. So computer system are dividing as a software and a hardware. In the software, it is an application software or system software. In the system software, operating system, utility software, and device drivers. And these are the under the software. What are the hardware means? Input device, CPU, output device, ALU, memory unit, control unit, and primary memory, secondary memory. These are the hardwares. We need some ICs. Okay. Software means we have to install. Suppose I have a printer. So printer is a hardware or not? Yes, it is a hardware. How it is works? We have to install the drivers. Okay, install drivers. So printer is a hardware, but I need a drivers. Drivers are software or not? Yes, these device drivers are software. Okay, any of the computer or any of the device we need. Device is a combination of hardware plus software. So hardware means a combination of some ICs. Software means one drivers. Install the drivers. Okay. So I'm taking any of the mouse or keyboard, printer. So any of this hardware, we need software or drivers. We need install drivers. So here also I need, if you are taking the input device means I'm taking keyboard or mouse. Okay, CPU. Output device means I'm taking as a some printer. So printer is a hardware, but I need a drivers. So arithmetic logic unit, it is also one type of IC I need. So memory unit. Okay, memory unit is I need a hardware device. Control unit also. and primary memory. Okay, inbuilt RAM and ROM. Secondary memory is external disk drives or secondary memories. Okay, so software, application software, software, operating system, utility software, device drivers. Okay, these are about the software, and these are about the hardware. Okay, so computer is a combination of software and hardware. Okay, and a simple instruction set architecture is a designation of instruction set architecture is the most important in the designation of microprocessor, and a poor designing of instruction set register to leads the bad microprocessor. But designing ISA designing must evaluate the trade-off in the ISA specification. A good way to start designing of instruction is a architecture to design of the this one. Okay, and the processor to be used for general purpose and specialized processor. Okay, when I'm taking the general purpose, we have to go for the completeness of the orthogonality. Suppose I'm taking a jump function, it is a different instructions we need to perform the operation. And register set means a set of registers. We have to take any of the register, we have to need CPU and memory. Okay, and instruction set architecture is the part of processor to visible the programmer and the compiler writer and the boundary between the software and hardware, and briefly describe the instruction set of the memory of the microprocessor. And instruction set architecture is a describing in 5 categories. That one is a operand location, operation, type and size of operation, and stack. Just now we discussed stack, accumulator, and GPR. Okay, it is the one type of accumulator, and GPR are the instruction set architecture. Okay, so in the previous slide we discussed accumulator and general purpose registers are the architecture. A simple instruction set architecture. Okay, so these are the simple instruction set architectures. So in the organization of a computer, we have to go for the what is the digital computer system and how we are exhibits the interconnection of a digital module, and how registers are decoding arithmetic elements and controlling. These digital modules are interconnected to some common data, and the digital modules are best defined with some common data to the operations, and the micro operations are performed and stored in a register. And the micro operation is a elementary operation performed on the information stored in one or more registers. For example, I am taking the shift, count, clear, and load are the micro operation performance. And the hardware organization of the digital computers are the following specifications are there. The set of registers are contained in the function. The sequence of micro operations performed on the binary information stored in register, and the controls that initiates the sequence of micro operations. The internal organization of a computer is defined as set of registers and their functions. The micro operations allow the micro operations provided by the organization of a computer, and the control signals are initiating the sequence of micro operations, and the symbol notations are in the describing as the micro operations called register transfer language, RTL. So what are the organization of a computer means? Register transfer, bus and memory transfer, arithmetic micro operations, logic micro operations, shift micro operations, and control memory, address sequencing, memory programming, and design of control unit. These are the organization of a computer system, and the symbol notations used to describe the micro operations transfer among the registers are called a register transfer language. A register transfer language is a system to expressing a symbolic form of micro operations sequences among the register of a module. So these are the register transfer language instructions, and some of the memory address register and memory data registers, and it denotes the part of a register, and it is showing as a size of the register 8-bit or 16-bit, and it is denote the transfer of information less than or equal R1 to R2 or R1 to R2 to R1, and what is the conditional operations R2 greater than R1 or if conditions like this, and the another name of is already existing in the register alias. And what is the connecting register means a digital system with many registers are impractical to have data, and the control lines are directly allow each register to be loaded with the content of every possible other registers of n minus 1 lines. Instead, to take the different approach, we have to centralize the set of circuits to data transfer and the control circuit to registers to source, which is the destination. It is about the connecting of the registers. Okay, and we are how we are organizing the computer means CPU and memory unit and input output. In the CPU, ALU, control unit and registers are combined, and in the main memory means primary memory and secondary memory. So secondary memory is a disk or externally connected peripheral. Input outputs means disk, monitor and printer, mouse, keyboard. These are the input output devices connected to this one, and it is the organization of a computer. Memory is connecting with CPU through the bus, that is address bus, data line, data bus and control bus, and this CPU is internally connected to input output bus. Input output means it is interconnections of the externally connected devices, means mouse, keyboard or printer, etc. These are externally connected, that means peripheral devices connected to the input output bus. And it is about the computer system. Computer system totally dividing as software and hardware. In the software, application software and system software. In the system software, operating system, utility software and device drivers. In the hardware, input device, CPU and output device. In the CPU, arithmetic logic unit, memory unit and control unit. In the memory unit, primary memory and secondary memory. It is about the computer system. So it is discussing about organization of a computer. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.